Hello and welcome from the A-Level Chemistry team at Long Road Sixth Form College. Unfortunately, we're unable to welcome you into the department in person at the moment, so instead I've made this presentation to tell you about our A-Level Chemistry course, to explain our approach to teaching it and hopefully to give you some insight into what it would be like if you came to study chemistry with us. So to introduce myself, my name is Simon. I'm the course team leader for chemistry, and you can see the whole chemistry team on the screen now. There are two other chemistry teachers at the college, Bridget and Zoe, and there is our chemistry technician, Sarah. Now, we are a very approachable team, and so whichever class you end up being in, you'll get to know all four of us very well by the end of your course. So let's begin by thinking about why you might consider studying chemistry at A-level. Well, first of all, it's an essential qualification for many career pathways. Things like medicine, dentistry, veterinary science, pharmacy will all require you to have an A-level in chemistry. A-level chemistry will also open up a huge range of university-level science and engineering courses, and it's a facilitating subject, which means if you're interested in studying a non-scientific course such as finance, law and politics, chemistry will be a qualification that's looked upon very favourably and allows you into those areas as well. And of course, even if you aren't considering going to university, if you want to go into employment or to do an apprenticeship, chemistry will help you develop your employability skills. So you'll get better at data analysis, maths and literacy, and of course the practical work itself and developing practical skills. If you're interested in finding out more about how chemistry might be useful in a range of different careers, the Royal Society of Chemistry has an excellent website, and I've put the link on the screen there, and they profile all kinds of different jobs and explain how chemistry is useful in those areas. Now, our chemistry course is the OCRB course, and it's sometimes called Salter's Chemistry. Now, this course was developed by the Science Education Group at York University. It's a context-led course, and it has a great emphasis on how chemistry happens in the world around us. It's very up-to-date, and it has links to many modern-day applications and to current research in chemistry. And there are several reasons why we really like the Salter's Chemistry and why we chose to teach it. The first is that it's a spiral curriculum, which means you get frequent repetition and development of key skills, and I'll go on to show you an example of that in just a moment. It also has a strong emphasis on understanding and valuing practical work. And we think that chemistry is a practical subject. It's built on practicals and the results of experiments. So we think valuing the practical work is highly important. It's also very up to date, and it's got good contextual information through 10 chemical storylines that makes it very relevant and interesting to study. And I'll explain a little bit about those 10 storylines now. So you study 5 storylines in year 1, and I've very briefly listed what they are on the screen. So we begin with one called Elements of Life, which looks at how elements form in stars, looks at models of atomic structure and how we might count atoms. We then go on to a storyline, Developing Fuels, and this introduces organic chemistry, and we look at energy changes in reaction and pollutants and catalytic converters and how you can remove those pollutants, all within the context of fuel. Elements from the Sea is the third one. That's looking at how you can get elements like bromine and chlorine, halogens and their halide compounds from seawater. We look at the ozone story, how reactions in the upper atmosphere are causing ozone depletion and what the effect of radiation is on molecules. So we learn the theory necessary to understand that storyline. And then we go on to What's in a Medicine, which is another organic topic. It's looking at the kinds of molecules that make up medicines and how you can synthesize them and how you can use spectroscopy to characterize them. So those are the 5 we cover in year 1. There's another 5 in year 2. And again, I've put a very brief summary of them on the screen. But we've got Polymers of Life is the first one we start in September of year 2. That's looking at condensation reactions and how those can be used to build up some really complicated structures, particularly proteins and DNA and RNA, biochemically important molecules. We go on to Oceans. So looking at the solubility of ionic compounds, why they're often soluble, how you can calculate the pH of a solution, and some thermodynamics about how you can predict whether or not a reaction is actually going to happen. There's another storyline called the Chemical Industry. That really looks into the detail of rates of reactions and how a reaction actually occurs, so you could design an industrial process to make use of that reaction. There's Developing Metals, looking at transition elements and complex ions and the colour and electrochemistry of those elements. And then there's one on colour at the end of the course called Colour by Design, which looks at how electrons are involved in causing a dye molecule to be coloured, and how you can synthesize a dye and attach it onto a fibre. So those are the storylines, those are the contexts in which you would study the chemistry. And each time you would learn enough theory to understand that particular storyline. Now what that means is that it's a spiral curriculum, and you come across some key ideas multiple times. And each time you come across a key idea, you develop your understanding of it a little bit further. You consolidate what you've already done and you take it a bit further and learn a bit more. And I can show you what that means in the context of molecular shapes. Now, molecular shapes I don't think really features very much in GCSE courses at all, but it's very, very important at A-level and beyond. And so we'd encounter it for the first time in our spiral in September of year 1. We'll begin looking at the shapes of very small molecules like the ones I've shown on the screen. So, 4, 5, 6 atoms in. We look at how you can work out the bond angle, what causes the shapes, and why there are slight differences between the angles in similar sized molecules. So for example, why water has 104.5 degrees, whereas ammonia has 107 degrees, and methane is 109.5. We look into those basics and understanding how you can work out the shape of a small molecule. We then move on to the second storyline, developing fuels, but we'd use what we've already learned about shapes to understand fuel molecules a bit better and go a bit further. So we look at something like C7H16, which is the molecules at the top of the screen there. Could understand their shapes, but also how you can distinguish between them and identify isomers. Once you've understood the shape, you can start to identify isomers. Also in that topic, but probably a bit later in the year, around December time, we'd start to look at the influence of double bonds. Again, we could work out what the bond angle was, but we'd start to understand why that gave you restricted rotation and what that had, the implications of that were for the shapes of those molecules. We'd come across shapes again in year 2. So around about September time, when we do the polymers of life storyline, we start looking at protein structures, DNA structures, but we could apply what we learned about shapes in year 1 to understanding better the shapes of these really complicated molecules in year 2. And you can see there's the structure on the right hand side of an enzyme, really complex structure, but you can understand many aspects of that structure using the simple ideas we develop in year 1. We also here look at mirror image molecules and optical isomerism, and that's also very important applications in biology, biochemical systems, and there's an example of limonene. We then come across shapes again in year 2. This is in the chemical industry storyline, and we start looking at enzymes and how a substrate can bind into an enzyme. So there's an enzyme binding a drug called captopril, and the shape is really important. So if you want to design a drug to interact with a particular enzyme, you have to be able to understand the shape of the enzyme and hence the shape the drug molecule needs to have to interact with it. And so there would be 4 occasions. There are others where shapes come up, but there's 4 occasions where shapes come up in the chemistry course. Each time is getting progressively more complicated, but it gives you an opportunity to develop your understanding and consolidate what you've already learned. The assessment of the A-level course is 100% by exams at the end of year 2. So all the papers will cover all the material. So anything from any of the storylines can come up in any of the 3 papers. But I've listed what 3 papers are there. They really differ in terms of what the types of questions are that you get asked about. They've got some very specific percentage weightings, but paper 1 is effectively multiple choice and some longer answer questions. Paper 2 is longer answer questions and a question on an article that is released in March. So it's called the advance notice article, so you can prepare for that question in advance. And paper 3 looks at your understanding of practical work. It isn't a practical paper, it's a written paper, but it looks at your understanding of practical work that you've developed during the 2 years. You're also assessed for the practical endorsement. This is common to all A-level sciences, not just chemistry. And you get either a pass or a fail for that. That's usually a requirement that you pass that to go on to do science at university. But that's assessed separately, and it doesn't contribute any marks to your actual grade. As I've said before, we really enjoy the practical element of Salter's chemistry, and we do a lot of practical work during the 2 years. So here's a picture of one of the year 2 chemistry class doing a practical. So it gives you an idea of how the lab might appear. The practical endorsement requires a minimum of 12 experiments. Now with the cohort we had last year, we did 30. So we did well over double the minimum amount, because we really enjoy that and think it's an important way of communicating the chemistry. So you'll do plenty of practical work, and most of our students really enjoy it. We have 2 labs. equipped with fume hoods. You can just about see the fume hoods in the background of the image on the screen. And usually you'll work in pairs with another student to try and understand the practical, get it done, and then to do the analysis afterwards. We also have a separate topic at the end of the course, our own storyline in a way, which is to summarise the practical work and prepare you for that paper 3, the experimental paper. In terms of teaching, you'll be in a group that's typically 18 to 20 and wouldn't go above 22, and that's because we need to be able to do the practical work safely and have space to get all the equipment out. So the maximum would be 22, 18 to 20 is typical. You get 3 1.5-hour lessons in a week, and whichever class you're in, whoever your teacher is, all our chemistry groups study the same content in the same week, which is an excellent way of helping you study with someone from another class, or if you need to come and get some help, you can come and find any of the chemistry teachers, and we'll all know exactly what you're studying because we've been doing it with our classes in that week. All students in chemistry would also have common assessments, common homeworks, and common preparation work, and I'll say a bit more about the preparation work in a moment. In terms of what you'd have to do each week, I mentioned preparation work, so we give you a module guide for each of the 10 storylines, and it has a piece of preparation work in it for every single lesson. So each lesson you have to come having already done some of your work and done some preparation, try to teach yourself something new. That gives us more time in the lessons for looking for misunderstandings and doing more challenging questions. In each lesson, you get a numbered handout. So I've got a couple of examples here. This is from the What's in a Medicine storyline. So you can see that's the first 2 lessons. It's part of their handouts. That helps you structure your study. It gives you a very clear sort of aim of what it is you need to learn in that week. So you'd get 3 of those in a week. And then we'd add a weekly homework that would consolidate and extend your learning, not just on what we've done in class in that week, more generally on chemistry, and keep ideas in your mind. And we have a starter calculation at the beginning of every lesson, because we've realised that that is a great way of developing the key skill of doing a calculation. It gives our students more confidence at tackling them in exams. Now, we're very aware that chemistry is a difficult A-level, a challenging A-level, and so we've really carefully designed the course over the years in order to support our students across the full range of grades. But whatever grade you're likely to go on to get, we realise that at some point you're going to find something difficult in the A-level course. So we've put many things in place to try and help you. We've, as I've said already, put a lot of effort into organising the course as well as we can, providing some weekly structure and helping you with your time management for your studying. We're really aware that we need to bridge the gap between GCSE and A-level. So the first storyline, the elements of life, and to a certain extent developing fuels as well, they are clearly designed in a way that starts where you're familiar from GCSE. We reteach a few key points, go over them again, and then we go into some extension. By the time you get to Christmas, you should be able to look back and see you made a huge amount of progress in chemistry, but hopefully the jump isn't too stark and it is a bit more of a gradual transition to A-level. The preparation work is a key part of our support. We've spent a lot of time preparing suitable work for you to do in advance. It all has a revision component in it, and that helps you keep on top of things you've already learned and stops you forgetting stuff that you did a long time ago. We've got a virtual learning environment called Moodle that's got loads of resources in, so you can go back over lesson content. It's got copies of our lesson PowerPoints and things on it, and it's got loads of practice questions that you can do to develop your understanding. We also know that everybody's an individual, and you may get stuck on something that nobody else gets stuck on. And so we have Subject Plus sessions on Tuesday and Wednesday afternoons. These are opportunities for you to drop in and get one-to-one help with a chemistry teacher on something you're finding particularly difficult. And we have all our answers and mark schemes are available. They're on the Moodle environment, and they're also copies in the library. So you can study in there and make sure you're answering the questions and getting them correct. So we think those things there will help you with your study of chemistry. In terms of enrichment, we're very keen for our students to do more than just the basic A-level, so have a much wider experience of the subject of chemistry, and so we offer several things to help with that. Every year we enter students for the Cambridge Chemistry Challenge and the Chemistry Olympiad. These are international competitions with very challenging questions in. You can see a picture of a few of our certificate winners there from a year or so ago. We offer a lab-based extended project qualification. So this is an additional qualification that you would have as well as A-level chemistry. I'm going to say a bit more about that in a minute. We have careers guidance from the Royal Society of Chemistry, and each year we organise some visiting speakers, trips to universities for open days, and some site visits as appropriate. And you can see we had a visit there from Anglia Ruskin, who came in to help our students with analysing spectra. Now, the extended project qualification is something that gives you a real opportunity to go into depth in an area that you're interested in, and as I say, get another qualification. So here are 3 of the students who did that qualification this year. So Oliver did an experiment looking at optimizing the methods for determining the rate of reaction between zinc and hydrochloric acid. Now that might sound straightforward, but actually it was a really complicated process to get good quality data with small errors in. So there's a lot of work went into that project. Alessandro, he looked at synthesizing aspirin in 5 steps, starting from anthranilic acid, and on his screen in the background is the method he used, or the scheme he used, and it was a really complicated set of synthetic steps that we'd never done in the department before. And Cherub, on the right hand side there, he also looked at synthesizing aspirin, but his project was slightly different. He was looking at methods of recrystallizing aspirin, purifying it, and then testing his product to see how pure it was. And again, that was really challenging to get good quality results. So there were 3 excellent projects. And you could study anything you like in your extended project as long as we could actually carry it out in the lab. And so we normally talk to students midway through year 1 about areas of chemistry they might be interested in studying. I want to say a little bit about results, because we're always asked about this at parents' evenings. And I want to show you the value added analysis, because I think that's the most important, because that shows you that regardless of what grade you end up with, it shows you how well you can do compared to where you start. And this graph takes a little bit of looking at, but it's got some categories along the x-axis there. It's got attendance, retention, pass rate, achievement rate, high grades. And then it's got some vertical bars on. If the bars are above the 0 line in the middle, that means that our results were in the top 50% of colleges. This is for sixth form colleges only. If they're above the yellow band in the middle, that means we're in the top 25%. And if they're above the red line, we're in the top 16% nationally of sixth form colleges. So we're really pleased with these results, because you can see for retention, achievement and high grades, we're in the top 25. And for the first 2 of those, the retention and achievement, we're in the top 16% nationally of sixth form colleges. And that means that our students are starting the course, we're keeping them on the course, that's the retention. They're passing the course when they stay on it all the way through, that's the achievement. And they're achieving good grades. High grades is above what you'd expect nationally. So we're very pleased with those results. In terms of destinations, about half to 2/3 of our students each year go on to university. They go on mostly to science related courses, not always chemistry, but science related courses. And I've put up a list here, a selection of the destinations of our 2019 cohort. So you can see there are some chemistry and biochemistry courses in there. There's also quite a lot with medical links, and there's a couple of medicine courses in there as well. There's bioveterinary science and midwifery and engineering, so there's sort of science-based courses that I've selected. And then there are also some others that weren't directly science related, but the chemistry has been a useful qualification for getting into them. So you can see accounting and economics there. Many of our other students go on to do apprenticeships, and so in recent years we've had several students go on to degree level and high level apprenticeships at GlaxoSmithKline, AstraZeneca, LGC and Source Bioscience, to give a few examples, and also level 3 apprenticeships at Addenbrooke's. So I hope that's given you some insight into what it's like to be a chemistry student at Long Road Sixth Form College. If you have any chemistry related questions, there is my email address, and you're very welcome to send me an email and I will try to answer your questions. Otherwise, thank you for watching, and we're very much looking forward to welcoming you in person into the chemistry department very soon.